Welcome to this BBSA training video on U-values and why they matter. A U-value is a measure of thermal transmittance and represents the amount of heat that can pass through an object. U-values in general tell us how effective a material is as an insulator. We can calculate the U-values of all sorts of building products such as bricks, insulation and also windows, blinds and shutters. The lower the U-value, the better the material is as an insulator, and the less money we spend on heating bills. Over the last century, the insulating properties of a typical wall in our homes have improved tenfold. This is due to improved building materials and methods and stricter building regulations. Today, a modern cavity wall will have a U-value of around 0.2 watts per metre squared Kelvin. But what does this actually mean? Watts is the measurement of energy loss. Meters squared represents the surface area of the material, and K stands for Kelvin. In this calculation, it is the temperature difference between the inside and the outside of an object, such as a wall of a building. We've just seen how walls have improved in energy efficiency over time. Now let's look at some typical window examples. A standard single-pane window has a U-value of around 5.8 watts per metre squared Kelvin, whereas a double-glazed window has a typical U-value of 2.9, which makes it twice as effective. Some high-performance types of glazing have U-values of around 1, which is almost 3 times more efficient than double-glazed windows. So let's assume we have a house with 20 square metres of single-glazed windows, and the temperature difference between the inside and outside is 10 degrees Celsius. We can now calculate how much energy we are losing through poorly insulated windows. We multiply 5.8 for single glazed windows by 20, the surface area of the windows, and also by 10, the temperature difference. This shows that 1,160 watts or 1.16 kilowatts of energy is lost just through the windows, which is about the same amount of energy used to power 5 computers. Let's have a look at a thermal image of a house. Red here indicates the highest levels of heat loss. Despite the improvements in glass technology, windows are still a weak point in a building's insulation. Windows lose heat in 4 main ways. Firstly, conduction. This is the direct loss of heat through a window. Secondly, convection, where the warm air in the room hits the cold surface of the glass and cools the air inside the room. Thirdly, radiation and re-radiation. This is where the cold surface of the glass absorbs the heat from the air in the room. And finally, air leakage, which is the heat loss through any gaps in the frame or poorly fitted glazing. Blinds and shutters will always improve the U-value of a window as they act as another insulating barrier. This graph demonstrates the energy-saving benefits of blinds. These will be more apparent when used with windows that have high U-values. Blinds have the potential to improve the U-value of single-glazed windows by over 40%. Even high-spec glazing will have its U-value enhanced by at least 10%. U-values of blinds and shutters vary depending on the thickness and construction of the material, coatings that are applied to the material, the air gap between the glazing and the blind, or any other gaps around the extremities. So let's just recap. A U-value is a measure of a material's ability to transfer heat and indicates how effective the material is as an insulator. The lower the U-value, the better the insulating properties of the material. Blinds and shutters will always improve the overall insulation and the U-value of a window. Don't forget, improving the U-value will reduce your energy bills and save you money. For more information, visit the British Blind and Shutter Association Knowledge Hub for other videos about the benefits of blinds and shutters.